Okay, welcome to day 6 of Advent of Code 2023. So this one is entitled Wait for It. Spoiler alert, we need to wait. So, the ferry quickly brings you across the island. After asking around, you discover that there is indeed normally a large pile of sand somewhere here, but you don't see anything besides a lot of water and the small island where the ferry is docked. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races. Open to the public. Grand prize is an all-expenses-paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat race just in time. The organizer explains that it's not really a traditional race. Instead, you'll get a fixed amount of time during which your boat has to travel as far as it can and win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, and that lists the time allowed for each race and also the best distance that has ever been recorded for that race. To guarantee you win the grand prize, you need to make sure that you go further in each race than the current record holder. The organizer brings you over to the area where the boat races are held. Boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but the time spent holding the button counts against the total race time. So you can only hold the button at the start of the race, and boats don't move until the button is released. So we have this input here. So this lists out just the time and the distance for that particular race. So 7 milliseconds, the total distance was 9, 15 and 40, and then 30 and 200. So the toy boat has started to as a speed of 0 millimeters per second. For each whole millisecond that you hold down the button at the beginning of the race, the boat's speed will increase by 1 millimeter per millisecond. So, because the first race lasts 7 milliseconds, you only have a few options. Don't hold down the button, that is, hold it for 0 milliseconds at the start of the race, and the boat won't move. It will have travelled 0 millimeters by the end of the race. Hold it for 1 millisecond at the start of the race, and then the boat will travel a speed of 1 millimeter per second for 6 milliseconds, reaching 6 millimeters. Then we get hold it for 2, giving a speed of 2 per millisecond, and that will go a distance of 10. 3 has 4 milliseconds left, it will go 12, and then we start to go in the reverse of this, so 4 milliseconds, and then 3 milliseconds remaining, 12, 10, 6. Hold it for 7 milliseconds, that's the entire duration of the race. You let go of the button, and the boat can't move until you let go of the button, and please make sure that you let go of the button before... Please make sure that you let go of the button so that the boat starts to move 0 millimeters. So this has started to reverse itself. So yeah. Since the current record for this race is 9 millimeters, so for the first one, there are actually 4 different ways that you could win. You could hold down it for 2, 3, 4, or 5 milliseconds at the start of the race. So here's the 2, which will give 10, which is greater than 9. 3, 4, and 5. So 3 and 4 give 12 millimeters total, 5 gives 10, which all beat that current record of 9. In the second race, you could hold it for at least 4 milliseconds, and at most 11 milliseconds, and beat the record. A total of 8 different ways to win. Finally, in the third race, between 11 and 19, total of 9 ways to win. To see how much margin of error you have, determine the number of ways that you can beat the record in each race. In this example, if you multiply these values together, you get 288. Determine the number of ways which you could beat the record in the race. What would you get if you multiplied all these numbers together? So each of these are races. We need to determine how many ways we could win each individual one, multiply all of them together. Now, the input for the test is obviously for the example is obviously here, and then we can very quickly have a look at the input here for the actual input, and we only have 4. So my initial thought was this was quite a small puzzle for day 6. I thought it was going to be a lot harder. It was indeed a very simple puzzle. There's probably a better mathematical way of doing it, but again, just to solve it, I did an iterative approach, and that's what I'm going to go through today. I've also added, a bit different to previous videos, but I've added a test here. So this is where I'm actually going to put the tests for the example to try and solve this before actually then running the full input, which will also then just run the test anyway, but just figured why not use PyTest. In fact, let's get rid of the test output here. Cool. Okay, so to solve this, really simply, what we need to do, if we're going to go for an iterative approach, which, simplest option to start with, without getting too mathy, because I didn't have time to figure that out. It's just combinations of how much time is the button held, how much time is left, how far will the boat go, and therefore, will it beat the current record? If it will, increment a count of how many times for that particular one it will win, and then multiply all of them together. So let's give this a little go then. So what we want to do is firstly set up this test a little bit better. So at the moment we're just deciding that everything's false just to make sure that the test was working, which it is. So what we want to do is assert that solve with the test input is equal to, and then the example that we have down here is 288. There we go, so 288. So if we just very quickly save that, head over to here, run that, so we get that this has failed because 0 does not equal 288, and we know that it's 0 because we're just returning total, which we just set to 0 to start with. Cool, okay, so let's get started. So the first thing we need to do is pass the input. So the way that I did this was kind of just doing the split lines twice, and then just getting all of the numbers out of here, and then all the numbers out of here. So I didn't bother using regex for this. I just split it by space, removed anything where it was an empty string. So let's give this a go. To get the times, so let's do times is equal to, we're going to have a list. We want to turn all of them into numbers. So let's say for x in string dot split lines, As you can see, I've got my LSP set up properly now, which was has been a lifesaver. I'll link to a playlist or a few videos by, I believe it's TechCraft, which I've been following and getting my NeoVim setup redone. So yeah, it's an incredible little series that he's put together. So yeah, I'll link to that in the description. Okay, so what we want to do here is remove the time part, and we want to then split that by a space if x does not equal an empty string. So that will give us all of the times. So then what we want to do is get the distances. So you can see what I've done here is just get the first entry from the string split lines, which is just going to give us the time row. So then this one we're going to use the distances. And this time we're going to do the same thing. We're just going to get the first row, or index 1, and instead of removing time, and also we're not removing time with an exclamation, we are going to be removing time without an exclamation, and this time we're removing distance. What we could also have done is just kind of find the colon and then go from the next character from the colon, but I decided to just use remove prefix for this one. Cool. Okay, so there we have the distances and the times. So what we want to essentially do is we want to go over each of these entries, and for every time between 1 and this limit, because this is how long the race starts, what we want to do is then get the distance that we can travel using the remaining time, and then determine and also how many milliseconds it will travel per millisecond left. Millimeters it will travel per millisecond left, sorry. And then determine, is it greater than the distance? If it is, we're going to then add it to the count and carry on. What we can also then do is, as soon as it starts to decrease below, so as long as count is 1, or at least count is 1 or more, and it's starting to dip below, so it's not going to be breaking, then we can not going to be breaking the distance, then we can actually just break out of the loop, because it's going to be decreasing from there onwards. So save checking things more than we need to. Okay, so firstly, let's go over all of these items. So we're going to be going over them in pairs: 7 and 9, 15 and 40, and 30 and 200. So we can actually use zip for this. So for the total time and the distance, I'm going to call it R, because I'm going to use distance remaining. In fact, R for record. Let's call it that. The current record. In zip, we want to go over the times and the distances. So this will give us a set of pairs. So we get the 7 and 9, the 15 and the 14, the 30 and the 200, because we're giving it this and this, we're zipping over it. That's what it does. It will give us the pairs. If you do have uneven lengths, it will stop at the shortest one. So if this top one was 3 and the bottom one was 2, it would only do 7 and 9, 15 and 40. It wouldn't do the last one if the distances one was only 2 in length rather than 3. Cool, so we're going to go over the distances. So let's say count is equal to 0, because for this particular race we have no idea how many times yet, so we're going to start at 0. So then let's just do for n in range 1 to the total time. We are then going to do the distance remaining is equal to n multiplied by, and what we want to do here, so we have the amount of millimeters, so we could call it m rather than n, but never mind, so it's up to the amount of time. We know that increments 1 millimeter per millisecond that the button is held, and we want to account for holding it up to the length of the race, or one less than the race length. So if it's 7 in total, we want to at least send it off with 1 millisecond left. So we're going to increment that. So we have the millimeters it can travel multiplied by the time minus how many milliseconds we have already held it for. So this will give us the distance that we can travel. So then from here, what we want to do is just check if the distance is greater than the current record. We're going to do count plus equals 1. Then I think if we do final part here of else or elif, count is greater than 0 and or if count is greater than 0, this isn't going to be true, so we're going into the distance is not greater than the current record, so we're then falling back down the other end, so we can then just simply do break. This should then just stop us from doing any unnecessary further checking. Because of the amount that we're doing, probably don't need it, but we'll leave it in there for now. So then finally, after we've done that race, we're then just going to do the total is equal to the count if total is equal to 0, else we're going to do total multiplied by the count. And then we return the total. So undefined, this is times. There we go. Right, so let's give this a go. Excellent. So we get, we've passed the test. So the test in this case was that using this input, we should get 288, which we did. So then, because we have used this little operator here, so only if the first bit was successful, the PyTest run part 1, only if that was successful, then run the full part 1, which gives us an actual of 741,000. And if we go down here, hopefully, yes, we get 741,000. Excellent. Okay, so then part 2. So if I just nip back over here, let's go to part 2. So for part 2, this ultimately is the same thing. It's just a parsing problem this time. So instead of going over all of the games, there is only one game here. So as the race is about to start, you realise the piece of paper with the race times and record distances you got earlier as actually very bad kerning. There's a little link there to describe what kerning is, if you need to know. There's also really only one race. Ignore the spaces between the numbers on each line. So the example from before, 7, 15, 30, 9, 40, 200, is actually 71,530 and 940,200. So now you have to figure out how many times you can win the one race if it lasts for 71,530 milliseconds. The record distance you need to beat is 940,200 millimeters. You could hold the button for anywhere from 14 to 71,516 milliseconds and beat the record a total of this many ways, 71,503, which I've just noticed is just that last little bit reversed. How many ways can you beat the record in this much longer race? So ultimately, we're doing the exact same thing. We're just passing the input differently this time. So what I'm going to do this time, I will just kind of set all this up again, just as I did before, just for the sake of retyping it all out. So what we want to do is assert that solve of test input is equal to 71503. Okay, so because ultimately this is just this is just the same thing as before. I'm just changing up the parsing. Let's just quickly write that out again. So we have the total. So for n in range this time we're just going to go with 1 to the let's call it the allowed time. We're going to get the distance is equal to the n multiplied by the allowed time minus n, and if d is greater than the, let's call it a record this time, rather than the shorthand of r, and let's then just say total plus equals 1. So again, this is a real iterative approach. So then this time let's parse it a little bit differently. So let's do allowed time is equal to, we want to convert it to an integer. We are going to then join, we want x for x in... No, in fact, what we could be able to do is if we do... so what I was initially going to do there is create an array, or sorry, a list of these three numbers and then join them together. But instead what we could do is just get rid of this and then remove all spaces. So if we do string, we want to go from string.find. Yep. We want to find the colon. We want to, let's just say +1, just to make sure that we're skipping ahead one. We want to go all the way to the end. Dot replace. Let's go with replace any spaces with nothing. And we just need to do the split lines. String, find the first colon, dot split lines, 0th entry. Let's just split lines, 0th entry, like this. Maybe that'll work. Yeah, let's give it a go. So then we have the distance. Sorry, the record is equal to this, and this time we are going to just get the first one, find that, replace all the spaces. Cool. And so then let's just try. We don't have 3 parts to any of these puzzles, so let's just do part 2. Okay, that seemed to work straight away. It took longer to run because we're going over a much larger span. We're doing the same thing that many times, but we are breaking out of it as soon as we start to decrease after we have increased a count. As soon as we are starting to move away from being able to beat it, we know that no more are going to be able to beat it. So again, this one 71503, and then the actual of 38220708, which we have over here. So yeah, ultimately this one was nice and simple. I thought it was quite surprising for day 6, but yeah, it was quite a simple problem. And then the changing it up was ultimately just changing how we're passing the data, and just repeating the same thing that we did before, but rather than it be 3 games, it's just 1 game. So yeah, I thought this was a good little puzzle. Yeah, nice, excellent. Right, so see you for day 7.